Right, so what we're going to talk about today, so Fred said we're going to talk about virtual instruments and a new product. This is actually a launch of a new version of a product which was called Load Dynamics Enterprise. It's now being rebranded on the 20th as Workload Wisdom. It is a new product, loads of new functionality, loads of features in there. But first of all, let's go into why it exists. So we're just going to talk about virtual instruments and then go through the product and then into a deep dive demo. I thought this was probably a good starting point. Quite a famous advert from the 1960s. Some of you may have noticed that VW are having one or two issues at the moment with some information that wasn't quite factually correct. So basically, they have developed the software within their cars to understand when it's in a test environment and reduce its emissions accordingly. And so when it went out onto the open road, it would then run perfectly as before. So that's causing them quite a lot of litigation issues, particularly in the US. Where it's having an impact now on EU law is that the EU Parliament actually set up their legislation on diesel use 15 years ago on the back of figures that VW had given them. So this is a huge can of worms that's just been opened up. So why am I talking about this? Very similar story with the IT industry. That if you go and decide, okay, I'm going to go and buy some flash storage, you are given a brochure and some statistics, and you're told this is what it's going to do. And almost certainly it won't. Your workload is very different to a lab test environment workload. And it's very important that you understand the differences between the two. So the Load Dynamics product was developed specifically to address that issue of taking your specific workload and running it against different environments. So the background to this technology was really with the big OEMs. So whether the hardware or the software vendors, pretty much every one of these uses this technology. And in the case of the flash vendors, they're spending over $1 million each, just in test and dev to make sure that they've got a third-party independent view of this and that everything works as it should. But you can never really, from brochureware, you can never really see how things are going to work. So Mark is going to talk more about that and go into the full kind of deep dive demo. So the idea of virtual instruments, it's really an amalgam of three product sets that came together. So Load Dynamics we talked about, then there was Virtual Wisdom, which is an application-centric infrastructure performance management tool. And then we also made an acquisition of a company called Zangati, which looked at monitoring into the cloud and gives us some kind of object and VDI capabilities, which is actually being merged into the Virtual Wisdom platform. Now, where this all works, if you look in the center of this diagram, you'll see a data center. So you've got servers going through switch fabric, going into storage in the back end. So the Virtual Wisdom product takes a feed directly from the hypervisor layer, so the virtual machines, takes feed from the switch layer and also storage, both NAS and conventional arrays, right down to LUN level within that, and brings that all together into a single view of that. There's a couple of changes that have happened recently in that. So conventionally, we would tap into the fiber optic network in order to get wire data as well as the machine data. Basically, every other monitoring tool is looking at machine data. They're looking horizontally across the data data center. They're looking at each of the tooling elements, and they're putting agents on it, and they're essentially polling each one of those elements. We do this in a different way. We are actually tapping into the wire itself, and then we're taking that line speed data and correlating that together with the information from the server switches and storage to give you a single view in real time without putting any load on the system. The slight change here is these guys, Cisco. Cisco like this technology. In fact, we've just signed a 1-year bi-directional deal with Cisco to provide analytics into their systems. So bearing in mind this is the third largest technology company in the world, this is quite a big deal for Virtual Instruments. What they've done is they have built telemetry streaming into the ASIC within their new MDS 32 gig switch. And the plan is that they're going to put that technology into all of their switches going forwards. So their arch rival, Broadcom, had got a small amount of analytics coming out of their switch. Again, they were polling the switch, so it was slow and it was averaged over time, and it's actually been dumped as part of the Broadcom acquisition, so we probably won't see that again. But Cisco wanted to do something more than that. So this telemetry streaming is coming directly from their switch into the system. They provide 30 metrics from that switch. A typical Virtual Wisdom installation provides 300 metrics. So it's not as granular, but it is good. It's basically customer driven. What do the customers actually want to see? So that's a big change. The other thing is we've done a partnership with Gigamon, which gives us the ability to put this technology into Ethernet. So it's no longer fiber channel only. So we're now block, file, object, fiber, ether, you name it, any hypervisor, any switch environment, any storage environment. So you can't hide anymore, basically. We load this up, it auto-discovers the environment, and it shows you exactly what's going on. So that's kind of this side of the chart. But today we're going to talk about the other side of the chart. So this is your production environment. This is your test and dev environment. And so we're taking a feed directly from this technology, but in this case, we're passing it through into the Workload Wisdom workload generator. Sorry, I'll just go one more. So just to give you a little bit of credibility on this, we have some good big customers, hundreds of big customers all around the world. But today, Mark's actually going to be talking about this lot here. So these are the technology partners that are really using this in anger. This is and has been available for 3 years now to end users. And that's the growth business, and that's what Workload Wisdom is looking at. But this is still core. All of these people are using this technology to keep themselves honest. Okay? At that point, I shall hand over to Mark.
Chris, can I ask, how are you going to be selling it with Cisco? Is it on their price list? Is it from the partners?
So we are a Cisco partner. That's under, there are various levels of partnership that you go through with Cisco. We're pretty much in at the bottom layer at the moment, where they can resell and whatever. So what we're trying to do is get to the point where their sales guys get quota relief and get full commission like it's a Cisco product in there. Cisco Live in Barcelona last week, we were doing customer swaps. It's basically they were wheeling their customers over to us and we were wheeling our customers over to them, which was quite fascinating to actually see, because I think the description I had, it's like two aggressive dogs sniffing around each other in a park at the moment. So there's these two sales teams that really don't know what the other sales team's going to do. And so by taking customers over, so like I took over one of our customers who is looking at a 40,000 port 10 switch refresh on his environment, which suddenly focused the mind of the Cisco guys of, okay, right, yeah, let's talk. And so there were half a dozen of those going in both directions. So yeah, it's a good starting point. Cisco have got quite a small sales team in terms of that MDS switch in Europe. So there's a guy called Fausto over in Italy. There's the German team seem pretty strong. They're doing it. The UK, there's really not anything that's been managed out of the US. So it's early days of growing that, but that's the plan anyway. But this is going. Our technology. We're let's get the terms right this week. Dell technology. EMC Select partner. We're a strategic partner with Hitachi, or what they're called this week. We're an HDS Select partner. So we've got these good relationships where we are selling the technology through each of those organizations. And so, Cisco again is at the same level within those partners. And so, we're not concerned about, are people going to get paid on this or anything. Okay, hopefully that answers your question. Yeah. All right, at that point, I shall hand over to Mark.
Thank you, Chris. So before I jump into the demo, Chris mentioned that the Load Dynamics, soon to be called Workload Wisdom product line, was very entrenched with the technology vendors, the big iron companies, right? The Dell EMCs, the IBMs, the HDSs of the world. They are all our customers, and really how they were utilizing this product was to test their development builds in QA departments. So they're looking to find bugs in their own storage stacks and to act upon that, basically giving them a lot of insight on how they can improve their products better. So we looked at that and we said, you know what, there is a huge demand out there in the market, especially the Fortune or the Global 1000 companies, IT organizations that share the same problems that the technology vendors have with picking what type of storage is going to be best for their environment, but what configuration, what workload is going to be most appropriate for the given storage that they select. So back in the day, we've actually gone through, this will be our third name change, but we originally were called Swift Test. So Swift Test back in the days, and a lot of the vendors that are still with us, a lot of the employees that are still working on it still refer to us as the Swift box, right? Well, we kind of realized that the Swift box is kind of ambiguous. In the dawn of all of the popularity of the cloud and object storage, a lot of people were getting confused and they thought the Swift box just basically was designed to test OpenStack. And although we can test OpenStack, that is not the only protocol that we cover. We essentially cover all of the major, most popular protocols and a lot of the original protocols that exist out there in storage technology. So change the name to Load Dynamics. Load Dynamics basically refers to the enterprise software piece and the load generation device. And again, to more properly align it with our overall company vision, we are going to change it again to Workload Wisdom, 20th of February. So real quickly, I just kind of wanted to show you the architecture, how all the bits and pieces kind of come together to make our whole solution. So you see on the right-hand side here, no, we don't put our software on a Mac computer, but this kind of basically isolates it and tells you that this is where our enterprise software resides. We are a software solution. We most commonly have VMs that basically get integrated on hardware that our vendors appreciate us just putting it on hardware. So Load Dynamics Enterprise Workload Wisdom is one component. That's what you will be accessing via a URL, and that's the majority of the interface that I'm going to be showing you today. So this is where you build your tests, you save your tests. We have a powerful backend database that basically stores all of these tests. This environment is not used very singularly. It actually is capable of a multi-user collaborative environment. So if you have an IT test team of 10, they can all have accounts on this system, and they can all in turn be running tests simultaneously on the system. There are some caveats, obviously.
Is it licensed per user, per test? What's the licensing model?
It's all you can eat. The only thing that we license are protocols. So say you were like a NetApp shop back in the day, you'd obviously want NFS v3 or NFS 4, NFS 4.1, any of those. So per protocol, everything else, all feature and functionality I'm going to show you is basically all in. So the software version, the brains of the solution is at one side of it, and then the other side of it is actually the load generation device, workload generation appliance. It's essentially a 2U appliance built on a Linux kernel. We basically take out all of the modules that we do not need in the kernel, so it's purpose-built to generate line rate speed out of the back. And as far as connectivity out of the back end, we carry a variety of different transport mediums. We've got obviously 10 gig Ethernet, we've got 25 gig Ethernet, we've got 40 gig, soon to have 100 gig Ethernet. And as far as the fiber channel protocols, 16 gig, 32 gig, and backwards compatibility as well. These ports actually can be mixed and matched for large enterprise environments that happen to not only have a fiber channel estate, but might also have a good bit of file or even object protocols. We basically give you the ability to have both Ethernet and fiber channel load generation ports on the device. Now for multiple users that have a desire to run tests simultaneously, you essentially would assign ports, load generation ports out of the device. They would be assigned, 1, 2, 3, 4 ports. Those would be theirs to use. They would not share those with their neighbors. Obviously, you can't generate two different workloads fighting for the same port. So the sharing of ports allows for the multi-user collaborative environment here. This particular device is designed to go into a test lab environment. Our customer base, that is the global 1,000 companies, the majority of these customers do have test lab environments, so that is no problem. Now, as we kind of move backwards here into this workload data import area and then to the production environment, this was a technology we built about a year and a half ago. It's been in the product for about a year and a half. And really what it gives you the ability to do is to gather array statistics from your production storage. So what is occurring in your production environment, all of those workloads. And what we basically do is grab these array statistics from your storage vendor's product. So if you're running a VNX, you've got Unisphere. If you're running HDS, you've got Tuning Manager. All of these reporting tools have very rich displays of statistics that they can present to you. So what we have gone and done is the ability for our product to read and understand a blueprint, if you want to call it that, of all of the different array statistics out there. So if we can take a CSV file of array statistics from Tuning Manager, we can upload this into our particular product. Immediately, our product understands this is Tuning Manager data. We'll then go out, parse all of those data columns, and in turn be able to turn around and create a workload and show you what the actual workload looks like. So let's dive in a little bit more on how this actually works. So this is the user interface here, available via a URL. So anywhere you can access the URL, anybody with an account on the system can essentially log in. And let's show you Workload Data Importer now, what we're talking about with these array statistics. So first, think about how hard it would be. So here's a given set of array statistics that call it XYZ. Any generic reporting tool is going to give you a bunch of array statistics like this. So picture yourself as an end user and how difficult it would actually be to try to put these array statistics together and actually simulate a meaningful workload that you could replay. First and foremost, you're going to probably have to stand up a lot of servers to generate the required load for this workload. We typically say about 10 1U servers equals one of our 2U form factor load generation appliances. We can generate over 1 million IOPS out of our load gen. So ultimately, our load generation device is called a lab in a box. So first and foremost, you would have to take these array statistics. You would probably have to have an Excel scripting guru that would be able to put these into some sort of a format that a freeware type tool like Iometer or VDBench or any number of the hundreds out there would be able to orchestrate. Well, then you would have to make sure that all of these scripts ran simultaneously and flawlessly on all of these servers that you stood up to run your tests. Then what happens if you run a 3-day test and one of those servers happens to fail while those results out of that 3-day test obviously are null and void because one of the servers died. So this way you upload, ingest the test, create it once, and you've got repeatability and scalability of the workload. So give a name for this. And then it's very simply selecting those array statistics. I select those array statistics and we ingest them into our system. Instead of just sitting here and waiting for this to finish, depending on how large the capture is, could take quite a bit of time to basically process all of these requests. So I will show you what the end result essentially looks like. So out of all of those array statistics I saw in those CSV files, we took all of that data and were able to construct a workload. So this particular capture appears to have begun 6:01 a.m. November 13th and ended 5:20 a.m. 14th of November. So as we move down and take a look at the legend, we can see latency reads, latency writes. It's got a very nice graph where you can take a look at it. We give you the most common key performance indicators which a customer would be most interested in. Obviously, IOPS. Can wait for this to load. So we've got the IOPS, the reads and the writes that can give you information there. And then we can just take a look quickly at the throughput. So there's the throughput. And then a very nice summary of what we basically saw in your workload. So average throughput, average IOPS, latency, the reads and the write block sizes. Majority of applications out there aren't a singular block size, obviously. So any of those block sizes that we've determined out there over the wire, we will take a look at and we will measure all of them. And then your read-write makeup. So this is essentially a fiber channel capture. Fiber channels essentially reads and writes. Well, what about all of those file protocols and object protocols that have a significant amount of metadata involved? Well, we would obviously capture all of the different metadata for NFS. We would take all of the RPC commands that we saw in the capture and give you a pie chart breakdown of all the RPC commands as well. So once we have all of this information, we can in turn replay this workload on your storage target. So if you're a large enterprise customer, you've got obviously a production workload environment. You also have a test environment where you want to make sure that everything is stood up and works properly before it goes into your production environment. So at this point, you would be able to replay this workload back in your test environment. And why would you want to replay it? Well, maybe you want to add more connections. Maybe you have 3 or 4 more applications that you want to add to the overall production workload. Well, how do you know that the storage is going to be able to keep up? It's going to be able to keep up with IOPS throughput. The latency is going to be satisfactory and it's not going to peg. Well, you can choose what ifs here when you generate the load. Say, okay, well, if I add more users, I'm in pretty good shape. So now if you actually want to go in and set the test up, this is a temporal workload that basically takes all of the aggregates of all of the different data patterns that we've seen in the system, and we generate it and have the ability for dedupe and compression. So if you're interested in data reduction and how it's going to affect the overall system, you've got that. We can also write to various locations. We can check for hotspots. Obviously, every application in the world is not going to write from offset 0 to the end, right? It's going to move all over the place and drift. You've got the ability to add drift in there. Product does support MPIO. So that's essentially one way of creating the workload. Now, a different workload that we've got the ability to create is a composite workload. Let me just get the composite workload. So let's say out of that capture that I got, it was of 1,000 LUNs. Well, out of those 1,000 LUNs, typically a lot of those LUNs aren't going to be doing much of anything at all during the given point of time when we took that capture. So we basically want to identify similar behavior that's occurring across these LUNs, and we group them into 8 different buckets here, basically isolating workloads. So if we take a look at this first workload, looks like this particular workload, we had 20 LUNs here. We got about 154 IOPS with an average request size of about 60K, 20 LUNs. This is the particular workload, and we saw these similarities on about 20 LUNs. And we kind of just move down and we take all of the similarities here. So this particular one was 68 LUNs. We saw about 15 IOPS on this one, 206K average request size. So we group all the similarities, and then out of these 8 similarities here, we thread these all together and basically replay them back. So for anyone really attempting to produce this on freeware and to synthetically run a workload like this obviously would take weeks, if not months, to try to fully orchestrate and then pray that everything works and all of those different components in that system do not break while the test is going on. So we give you the ability to basically ingest and replay. Does that make sense so far?
Sorry, are you saying that you're automatically detecting similarities in there, or are you saying you as the operator are noticing those similarities and choosing?
No, this automatically detects similarities. So out of all this data that we get here from all of these different LUNs, right, all these volume names and the time base right here, we're going to detect similarities that we see within that environment. And that's basically how we generate these different buckets and then in turn replay the workload back. We can get about a 98% accuracy, and using our virtual, the majority of the array reporting tools out there give you about maybe a 5-second polling interval or even higher than that. Well, with Virtual Wisdom, we get about a 1-second polling interval. So very, very granular data that we can pull out of Virtual Wisdom's captures and in turn replay them as well.
So this allows you to discover LUNs that have been created that you might not know about. This is using.
Yeah, absolutely. We're just reading off of that CSV file that's going to have a list of everything that's going on in a given point in time.
Right.
So every LUN, even if the LUN's not doing anything, if it's basically doesn't have any I/O activity running to it, we're still going to make note of that and say, okay, out of 1,000 LUNs, 25 of these LUNs were taking a break and weren't doing much of anything. We want to basically accurately depict that. We don't want to put that into an average somewhere that's going to skew the overall performance.
Are there PII issues around capturing and replaying all the data that you're...
What type of initiative?
PII,
Personally identifiable
information.
No, we don't take any personally identifiable information. The only thing, if your customer has the LUNs named, we'll have LUN names, but that's about it.
But you're capturing all the data, all the live traffic data that's going into the storage.
Yeah, we only take the reads and the writes and the metadata, so we can't see anything. I mean, believe me, we've gotten this question asked millions of times with big banks and everything else. There's nothing identifiable of what they're doing. We
So
cannot
how do you replay the data then into the storage as part of the test?
replay the data. So the reads and the writes.
Yeah, because are you just sending random data just to mix the pattern of the read and writes, or is this the actual data that was
PII in flight's not a risk. So PII.
This is what we're taking. So
there's going to be a cache of it
if
otherwise.
you're concerned about PII in motion, you need to be encrypting.
Yes, but
Nothing to do with this.
But it's
there's going to have to be a cache of the data.
There's no actual data.
That's capped.
there's no actual
It's
data.
just garbage.
This is what we get. This is garbage, right? Well, it's good garbage.
Yeah,
It's
yeah.
So I guess I'm struggling to see.
You're just generating synthetic read and writes. You're not
Exactly,
Using,
we're not-
using material data.
Exactly.
You're just
This-
regenerating the reads
So this
and
is
writes
just purely
in terms of
infrastructure
size and
tests, not for
performance.
application.
Exactly. Yeah. So we're not recording live data and replaying live data exactly.
Okay.
So there's
Are you
nothing
I was
identifiable.
misunderstanding some of
simulating the statistics of the day? data. Though.
Yes.
Mhm.
But it's simulating the workload
Yes.
characteristics.
Yeah,
so
Like how many
application.
how many
It's not the
IOs,
same
what
physical
properties.
pattern as the actual
Yeah.
data.
Yeah,
Not
I was
the data
misunderstanding.
itself,
Misunderstanding.
Yeah,
what
but
you
it's
were
a very
trying to
valid question for anything like that if you are
Yeah.
storing a pool of data for testing.
Exactly.
Yeah, because you're not allowed to do it.
Yeah. No, we get that question all the time, and we don't deal with the data itself. In fact, that's discarded.
understand.
I put that up in big letters up front. We do not do that.
Yeah, obviously this
Yeah.
feature would not be very popular with the majority of our customer base.
Yeah.
It did that. So back to the user interface, let's show you some of the examples of workloads that we have here. If you were a new user and you wanted to come in and actually generate a workload. So we've got examples of basically all of the protocols out there under the sun. So I'll just jog through these very quickly. You've got fiber channel workloads, NFS v3, 4.1, SMB in all flavors of SMB. Got iSCSI. You've got Object. We mainly support Amazon S3 and OpenStack Swift. You've got VDI workloads, iSCSI. And then these are basically just workloads based on protocols, essentially. We also have examples of very specific types of application workloads. So we've got a team of data scientists that perform research and find what at the very highest level would be a very good average of a given application. So what would be the best average of a fiber channel file server and what type of traffic it's generating? We have those. We've got Exchange workloads. We've got various versions of Microsoft Exchange. We've got SQL. We've got an Oracle database. We've got Splunk, online transactional processing, file servers. So many different examples. So if you were a customer and you just wanted a down and dirty, just very high level example of what a workload might look like, you can basically very quickly jump in here and run an example. Now let's move back to template and I'll show you how you would actually construct the workload. So let's take NFS v3 for example. So all of these right now are read-only templates. So very much like checking a book out in the library, you would check out the book, clone this to make it writable. Once I clone this workload, I go and edit it. Now I can start playing with various parameters. So very easy to use slider bars, so you don't have to be a scripting genius to orchestrate a very complex workload here. It's very much moving these slider bars to your read-write percentage. And then for NFS, the data versus metadata. Well, that's nice, but that's a pretty simple configuration. Most users are very concerned with the amount of metadata that they have in their NFS workload. One particular customer that we came in and helped several years ago, they were using Iometer to test a very giant NFS workload. They had a very high-end storage vendor in there, and it was costing them way too much money to be able to stay in business. So they were looking at a lot of alternatives. Software-defined storage was really what they were looking for. So they were trying to figure out what their workload looked like with Iometer. Well, one thing about Iometer is reads and writes only. It's not going to tell you any of this metadata information. We went in, we said, hey, you can't be testing an NFS workload with Iometer. You're going to get very minimal results that are going to mean anything at all. So when we came in, we took a look using the product. We found out that out of all of the traffic in their NFS environment, 88% of the traffic was metadata traffic. So only 12% of the overall traffic were actually reads and writes, and everything else were RPC calls in the metadata stack. So you can imagine how much they were missing by trying to test their workloads with freeware. So we went in, we basically showed them what happened, and were able to assist them in choosing the right size of this new software-defined storage so they could succeed with what they were doing. Again, the same. We can move these slider bars for our different aspects of data versus metadata. It's got to obviously up here make 100%. So as I move these, the circle basically completes itself there. So as far as a file system, I can have a flat hierarchy or I can have a tree hierarchy. So we basically will go in and create the file system, create the directory structures. If you have a tree structure with many different subdirectories, we go in and we create all of this for you. So you don't have to generate anything. So this gives you the ability to build. Now out of this NFS workload, what's my file size? Is it a constant file size of something? Or is it a distribution of file sizes? So I can actually go in here and build a distribution table of what all the different file sizes might look like here. And once I configure all of this, it's gonna give me a sanity check and basically say, okay, well, out of all of the files that we're going to be creating in directories and subdirectories, this is what your average size is going to look like, so you don't completely overwhelm the target when all is said and done and you start running the tests. Some of these are just kind of FYIs. We can sequentially generate names. So the reads, we do the same for the writes. We'll go in here and we'll give you the ability to generate the reads and the write block sizes. Write pattern, so sequential versus random, and async IOs, you can set those as well. Data parameters, so we've got a lot of different type of data that we can run. So constant data, sequential data, random data, just purely random data, seeded random, and then data reduction. So that's where dedupe and compression comes into play. In the dawn of all flash arrays, obviously the majority of them will use some sort of data reduction to maintain efficiency and speed in the all flash arrays. Load properties is basically, well, how much I/O do I actually want to send to the system? So we can delimit it out into various aspects. So if I want actions per second, better known as IOPS, I could go ahead and key in how many IOPS I want. And then concurrent workers, that's the number of connections, right? So if I've got 1,000 connections, I just go ahead and key that in. The same can be done with throughput. And if I just want to generate the max load possible, let's take this array through its tests, see how much it can do. I just select maximum workload there. We have ramp up and ramp down, which basically gradually ramps up the traffic that we send to the array targets. This is really an artifact, but it still maintains pretty legitimate today. Back in the days of spinning disk, if we tried to generate a ridiculous amount of traffic in a very short time, we found that we could bring the storage arrays down to their knees very quickly, and they would just go down for the count. So we give a graceful ramp up and ramp down period where we start sending it gradually, basically giving the array a chance to keep up here. Many debug parameters that we're not going to dive into, and runtime parameters. That's basically how long you want to run the test. So when all is said and done, if we want to take a look at the test results, let me just find these test results here. You'll run the test. It'll show you how much time has passed. Test will finish. And then you can go down and take a look at your results. So out of running an NFS v3 test, we're going to strip out all of the different RPC commands here that we see and give you a nice graph of what's happening here, all listed here as well. And there's your nice IOPS summary, your throughput summary, and your latency. Then we have another charting mechanism here, all charts. That's if you really want to dig way deep down into a given command or a given Ethernet detail, right? So we could go down as far as ARP, network bandwidth, RPC commands. So more information than a lot of IT users ever would want to see. But again, we give you the ability. We track quite a few statistics coming out of our overall tests here. So that is standard way of creating a test. Now, what if you have purchased a new piece of storage And you want a very quick and automated way to see where that storage target really shines and where it might have some weakness. What's it really good at doing and what's it really bad or challenged at doing? We have something called the iteration suites. And what the iteration suites allow you to do, that first test template that I was setting up for NFS, we had a finite reads, finite writes. All of these things were basically set in stone. But what if you wanted to see what would happen if I changed file sizes? How would the array perform if the reads and the writes, basically the block sizes went up and down? Well, the iteration suite essentially gives you that ability. So if I wanted to see maybe a read-write distribution of 50-50, then maybe 40-60, then maybe 30-70, we write all of these parameters, and you can separate these. It'll run one test at 50, it'll run one test at 40, 30. So as you can see, any of those different parameters that we're able to change on that initial menu, you can add those as iterations and basically waver the parameters there. We run one test after the other. So this particular iteration suite that we ran had a total of 23 tests. And it looks like what we were doing here was changing or iterating on the read access pattern and the read-write constant block size. So here I got 100% read, 64K blocks, then I do 32K blocks, 16K, et cetera, et cetera. And what this does is basically I tell it how long I want each test to run for, and it's basically going to do four corners testing on the storage array. And it's going to give you a lot of insight on where your best numbers showed up and where the array really had some challenges. And what we do is we basically find all of these high values and low values for you, and we indicate them in bold here. So looks like test number 12 with a 40% read and a 64K block size gave us the best throughput. And we got our best IOPS with a 40% read and 8K.
Do you do anything similar in terms of iterating, but not just varying parameters within a particular test, but actually running all of your workload tests that you've got in your standard catalog to say, hey, it's great for X type of workload, not so good for Y, and okay for the rest, something like that?
We can. We've got something where you can sequence one test after the other. So let's say you wanted to test an Oracle workload. You can queue up an Oracle workload, and then right after that Oracle workload, you wanted to run some other workload. You could queue all these tests up and just let it run for a week if you wanted to.
I was just thinking that you've got that library of tests, so you could run it and say, well, what is it like for doing final work? What's it like for doing an Oracle database? What's it like for doing a SQL server? What's it like for doing Exchange, etc., etc. To say, yep, okay, it's okay for these, it's rubbish for those, and it's good for these.
Right.
Just to give someone that overall picture without them having to make it all up themselves.
One thing that
Because
actually,
that's probably more interesting.
so one thing that you were talking about yesterday, which is there's one of the flash vendors kind of optimizes their system for a certain block size within, and so we won't mention any names, but it runs really, really fast at the specification they put. However, not everybody has the same block size, and so it's finding things out like that are interesting. In fact, when you get a bake-off on real workload between several vendors, it can vary really dramatically.
I'm not really a storage person. Is it really that much of a problem that storage vendors don't make equipment that works properly, that you actually have to test it like this?
Okay, very good question. Very, very good
I
question.
want the vendors to hate us.
Okay.
It just seems like the storage vendors make faulty equipment, and that everybody in storage seems to spend all their time working out how much faulty there is.
That's a pretty good description. So if you bear in mind that a typical enterprise is spending somewhere upwards of 65% of their IT budget goes into this region, getting it right, getting it sized exactly right, getting it tiered right, getting the application throughput, so that it all works is really important, and that's a bit of a challenge. So what we've had in recent history is, Flash has become affordable for the first time. So that's come in, and according to, most senior management that will have been down to a Gartner course or whatever, they'll come back, say, we need to replace everything with Flash.
Yeah.
However, it's not the panacea to everything. And the way the different vendors have set
Yeah,
up.
because some of them are like object stores put file
Exactly.
and block storage on top of an object store, and some of them are doing files and they slap an object interface on top of a file.
Exactly.
So are customers used to being abused like that in the storage industry? Like, are they stupid enough to buy that stuff?
So the reason that I put that car analogy at the start is if you go down to a car shop after this meeting and you look at the brochure and it says this car is going to do 45 miles to the gallon, you'll get in it and it won't. Fact.
Yep.
It's just a matter of how close to that figure it gets to. Because your workload, you're going to put 4 people and a dog and put a trailer on the back and drive it up the side of a mountain. Yeah, that's not a perfect test environment.
No.
So these guys are developing, they're not trying to dupe anybody. They're trying to develop the best, fastest, cheapest.
It's
thing.
more the case that in the past you bought storage for a single workload, so therefore you could test your proposed storage solutions
Against that.
adequately. Took an awful lot of time and resources, and you probably
Yeah, I mean-
you only did it for a limited set.
And you
But
would-
now you're moving more towards a situation where your storage is more general purpose.
Yeah.
And you
So-
also want to discover whether, if you've got a performance issue, is it in my storage, is it in my networking layer, is it in my
It's always in
network,
the
is it?
network.
It's always the cable, it's always the cable, it's
Well,
always the cable.
it's usually in the network because, as somebody
Sometimes-
who's a network professional who works with storage people, it's usually in the network because the storage people actually haven't gotten a hold of the idea of a network. They still think fiber
Well-
channel
Probably
is
it's in
mystical
the
magic.
software
But
workload, because something's opening a file panel 900 times when it doesn't need to.
yeah, that's
I mean,
much more
especially as
common.
the trend now is away from fibre channel to high-speed Ethernet. It's just your generic connector.
Well, that's one of those misnomer trends as well. It's not. The way I'd like to do this is I joined the Amdahl Corporation back in 1995 and was told that the mainframe was dead. So last year IBM had their best ever by capacity and revenue mainframe year. So it's taking a really, really long time to die. And fibre channel...
In areas where it's already installed.
In areas, yeah, it's not a great thing. Fibre channel is going to do a similar thing. So if you think that fibre channel is going to be replaced by Ethernet next year, it won't. It'll be around for a long, long time because it does a very good job of what
It
it's
won't be
doing.
around for a long time. That'll be around for a decade or so. It will die quite quickly by compared to other technologies because Ethernet, like I'm working with a vendor now, we're building out a 90 petabyte store. Fibre channel makes 0 sense, and we do a shared Ethernet backbone, and we're spending fractional amounts compared to a fibre channel or an IB network to build that out. Literally, like, the Ethernet network that'll go underneath will be less than £1 million, and it's non-blocking, blah blah blah, all the magic stuff that fibre channel is supposed to, all the fictional magic that fibre channel is supposed to have. The only reason a fibre channel worked is because you underloaded it. That was it. It just was never oversubscribed.
I mean, you wouldn't rip it out if you had it, but
Yeah.
you wouldn't.
Actually, most people are because
Yeah.
the cost of Ethernet is cheaper in maintenance. You can ROI it in the first year if you ditch the fibre channel and replace it with a decent Ethernet. That just means not Cisco, by the way. Because Cisco's, the pricing of Cisco gear isn't economically. It's like the old EMC story, right? Overpriced, oversold.
So, yeah, all I can say on that is working with some of larger customers that have got commitment to both camps. They are actively putting in new
Some of them
fibre,
have critical
new
systems
fabric.
running on fibre
now.
channel and they're not going to read.
Yeah.
So for them, this solution seems like perfect because I can replay and I can get 100% certainty that a new storage array can play my workloads to some level. We've been able to do this in networking, but nobody ever pays for it.
Yeah, well, interestingly enough, at the start of this presentation, I showed you both the production side and the test and dev side of our product set. So the production side, we're taking an application view, following an application from the user down through the hypervisor, through the switch, through the fabric, through right down to LUN level and back up again, and looking at what's it using and how's that optimized and whatever. And yeah, you say typically it's a network issue.
Yep.
Actually, most of the people in this room will find that it's usually the storage guy that gets blamed first. Yeah, the fingers point in that direction. And so what we're doing is getting rid of that finger pointing thing of actually saying, yeah, yes, there is an issue. Yes, we've flagged that up. Here it is. That's a different thing to this. This is all about your test environment. Let's make sure that everything is running absolutely optimally before it gets rolled out into production. So let's try everything. And there's a huge amount of ego, a huge amount of bigotry, actually. You know, people say, you know, well, I've always bought HP, and I'm not going to be dissuaded by that. Yeah, they take me to golf every Friday. And you know, in a bake-off with other technologies, I'm not picking on that company, but a bake-off, you'll just find, you know, that your workload needs something different, and there is a better solution.
The flip side of this is you just literally don't trust the vendors to produce a technology worthwhile, and you have to validate.
The important thing here is not,
Yeah.
I'm not saying don't trust the vendors, I'm just saying it's good to have an independent view.
No, I didn't say you were saying that. I was saying I'm saying that.
Okay,
I'm
yeah.
looking at this going, obviously, the storage vendors are so bad at what they do, we have to test their products to be sure that they actually work as they promised them.
I think that the storage vendors can never build to your custom environment. In the same way that they won't offer a service level agreement on performance of their kit in your environment. They'll do it in their own environment, but as soon as, yeah, they don't know how dodgy your code is. They don't know how, you know, what that environment is. So this is all about your environment showing how it's really going to run on that stuff, whether it's hardware or software.
Have you guys thought about crowdsourcing any of this information? I'm just thinking, because this would work wonderfully well in terms of like, you know, like this array is good for this and that array is good for that, but that would be so like, if it would be anonymized and shared, like, I don't know, some people do in storage, like Backblaze does it on hard drives.
Okay, so it's a very good question. We could take all the stats from all of the vendors, whether hardware or software, and put it out into the public domain. We'd have a really good fun week, and then we had no business at all from that point onwards. The confidentiality of this is actually very important to us. However, there is a website which we can show you, which is called
Workload Central.
Right? So this is where you can upload your workload to this site, and this is a pool. And so you can say, okay, what's this going to look like in Oracle 6? What's this going to look like on a new EMC? What's this going to look? Yeah, how's it going to work? And so this is a free pool that you can go into, log in, and have a hunt around in there. And so
you don't make people do this, but if they want to, it's like voluntary. But like if they want to share their work details, they can.
Absolutely, and this uses the same technology as that workload data importer I was telling you about. You're going to get your array statistics from your production workload environment, and you're going to upload them to this site. You'll see the workload, but you can't really do anything unless you have the product. That's my workload, and that's how it compares to somebody else's workload running the same thing. But if I really want to put the rubber to the road, I need the product to do that. So it's kind of like getting you hooked on the candy or whatever else you want to call it, right? This is early access, so it's still in beta, obviously. But we hope that at some point, you know, it's going to be a collaborative environment where people can actually gain intelligence on some of their workloads out there. Now, moving back to the whole fiber channel thing, fiber channel is expensive, and people are trying to find more affordable solutions. We see that as a very common use case with a lot of our customers. They've got a giant fiber channel estate, and they've been to enough seminars where they're saying, oh, move to Ethernet, you'll save a lot of money, the ROI is much better. And it's quite easy for us to basically simulate. So we'll take their fiber channel workload, fiber channel and iSCSI being similar in the fact that they're both SCSI protocols block-based, right? We can very easily change their fiber channel workload into an iSCSI workload and retest it on their target and let them kind of know and gain an understanding if they're going to lose anything or if it's sufficient for what they're doing. Another pretty common use case is change management. So take this example, a payment processing company had a large estate of a particular vendor. And all of a sudden the vendor said, hey, look, we need you to upgrade the firmware on all of your storage targets ASAP. We've got a lot of fixes, feature enhancements, and you'll get more performance. So they basically took the vendor's recommendation and blindly upgraded that firmware on their production systems. Well, a couple of settings happened to get changed in that firmware update, and it brought them down for a while. I can only imagine how many millions were taken down because of that. So now what they do is they have a production environment and a test environment that mirrors their production environment. Any type of change at all recommended by the storage vendor is tested in their lab environment on our product to ensure that everything is copacetic and nothing will break or slow down or any of that. So that's a pretty powerful use case as well. So moving back in here, now just kind of getting into some of the nuts and the bolts. So again, I said this is software. A lot of our customers appreciate the fact that we just integrated on a 2U white box solution, right, so that they can use it. But the generator, the actual generator with the HBAs connected to the back that's actually generating the load, if you want any type of max performance, max scale, that's obviously got to be hardware. So the software basically goes out and finds all these hardware load generators on the management network. So we've got some 1 gig Ethernet load generators here. We've got a fiber channel generator, and I mentioned before we can mix and match different protocols as well. So I'll go out and find this, and our load generators have up to 8 ports. If you've got a pretty complex storage environment, you can actually stack more than one load gen in there, and our user interface basically will find them all, and you're able to run tests on all of these different ports. If someone happened to be running a test on one of these ports, the green port would turn to red. That would very quickly give you information that somebody's running a test. I need to either wait or choose another port to work with there. Another aspect of the product that has to be done is what's called a test bed configuration. And really what a test bed is, the test bed is the relationship between the ports on our load generation device, how they plug into the customer's storage fabric, and then at the end connecting to the customer's LUNs, exports, shares, anything like that. So I've got a couple of examples here. I just find. So this particular test bed that I've got here, this client 0 indicates a port on our load generation device. So any given port here, I can just choose one. And then this is basically the connection. I can specify, an IP range. If I had DNS entries I wanted to add, VLANs, MAC addresses, any of that, I'd be able to add that in there. And I've got the service, which is basically, okay, what share am I going to connect to? So I've got an NFS share here, or export. I've got an SMB share here, and I've got an iSCSI share. So as you can see, all the information that we'll need to make a connection to that storage target is right here. So I put an IQN in, I see my LUN, and any other settings that I might need to configure with my storage device, we set up right here. Now once I have this test bed framework configured, this is really something I only need to do one time. It's the framework, and then all of those tests that I showed you would run against this test bed. So this is something I create once, and then our load generation device automatically understands how it's going to connect and what it's going to connect to via this test bed here. We've also got pretty rich reporting capabilities out of this product. So what I did here, we were running a simulation in our lab, and I wanted to basically plot IOPS throughput and latency all on one chart. So out of those umpteen different results and parameters that we can track, you can plot any one of these on a graph. So you can get as complex or as simple as you would like with these graphing and reporting capabilities. So we started generating a high load to one of our kind of aging storage targets in our lab environment. So as we generated more and more load, you see the breaking point where latency is going to absolutely spike and the throughput and IOPS are just going to tank. And we can report all of this information through the reporting mechanism here. Once I've got this report done, I can actually copy this URL, email it to my boss who wants to see the report. As long as he or she's got an account on the system, you can simply click on that URL and up the report comes here. So any questions so far? Covered a lot of the, most of the aspects of this system here. You got anything to say, Chris, as far as covered the majority of the information here?
No, it's just down to whether this all makes sense to you. To you guys, the principle behind it, how it's working, and who's using it.
So, you talked about this being under NDA. Is all of this new, or is it a new way of presenting some things that you've already had pieces of before?
It's the UI basically got a facelift. We've added some functionality in 6.0, our new release. We'll have a temporal SMB workload where you can actually capture metrics from Virtual Wisdom and replay them back in a time-based workload through our load generation device. So the SMB workload is new. We also, so imagine that test bed I showed you where we have the relationship between the load generator and the storage target. Well, we found that some iSCSI storage vendors out there require every LUN to be identified as LUN 0. Well, that could be painful if you have 1,000 LUNs. And before we added this new feature, it would take 2,000 mouse clicks to create all of these different IQNs and LUN names. So with 6.0, we have tabular entry. So you can take an Excel file with all of your different iSCSI IQNs, simply upload it into the test bed, and we will automatically generate all of those IQNs and LUNs for the particular device. So a fair portion of our customers will really appreciate this added into the product. What we've also done is significant improvements in our backend database. We're actually going to be about 80% more efficient in how we store data in our backend database, and our improvement as far as generating reports and the speed with which we can generate these reports will be increased by tenfold. So a lot of users that use this quite regularly will definitely notice increased performance in the overall usability, look and feel of the product. And then users that do run a lot of these tests, especially when you run that iteration test I was telling you about, where we deviate and we change all these values and run one test continuously, one after another, that's going to fill your database up pretty quick. And now with the more efficient use of space on this database, they don't need to worry. They're not going to get a warning message that we send when the database fills up to 85%, and then they basically have to spend some of their time going in and housekeeping, right? Cleaning up some of their old tests they don't want, making room. So now it's going to be they can run a lot more tests, and it's much more efficient use of our backend database. So we do integrate on hardware, like I told you about. A lot of customers with pretty mature hypervisor environments can actually use the virtualized version of this product. So what we'd end up doing is sending them a link. We have an application VM, which is the UI, and then we have a database VM. We have them install it on Xen Server or VMware, and they're able to run this UI basically from a hypervised environment. Again, the load generator requirement is hardware. You absolutely need hardware. Thought it'd be interesting to show you some of these blueprints or analysis policies. So out of all of the array statistics that we see out there, of course we don't have them all, right? So if we notice that a customer is sending us CSV file and it happens to be from a storage target that we don't understand, that we don't have a policy for, we go in and we develop a policy, and in the next firmware release, we basically have that new policy in there. So I'm just going to jog down some of the analysis policies we have. So HP3PAR, we've got On Command, we've got Pure Storage, EMC, Oracle ZFS appliances, so Tuning Manager. So many different analysis policies here specific to Vmax. And if we go take a look at what we actually have in here, this is what we're looking for. This is the data that comes out of that CSV file. And this is what we understand. This is how we basically translate it into something that we can perceive, and we can go and build the workload and replay it.
Is this something that would be amenable, for example, to machine learning, that you could characterize a workload and then do some deep learning on the statistics you've got back from all of these real-world tests and actually predict without having to do the real-world test?
I think that's a very interesting idea. Well, we definitely have a lot of the data. You could feed that into some machine learning environment and definitely come out with trends and to understand what's going on. I mean, right now we're working with a lot of vendors that have call home features, and we're trying to understand a little bit deeper what the call home metrics are and how we can basically construct those call home metrics into a workload as well. It's very interesting.
Are you getting any customers asking you if you could model some of these software-defined storage elements that just run on standard servers to see whether different servers might have a different impact or how they scale the software itself, things like this?
Absolutely, that's a good question. So what's really occurring, so HCI is extremely popular right now. Everybody's moving to HCI. So we do have some challenges testing the full encompassing HCI story, right? Mm-hmm. So if you've got an HCI solution and you can expose NFS, well, hey, we talk NFS. We can go in and we can test through the NFS gateway or whatever. But once you start abstracting the storage layer and the compute layer, that's a challenge for our product, right? We have a lot of things in works right now where we will be addressing a lot of these issues in the upcoming future with some more technology.
So how much memory, how much CPU to apply to each one, etc.
Oh yeah.
In this case, isn't it better to have instead of a physical workload generator, the virtual distributed workload generation test hyperconverged environments?
Yeah, so like I said, we can test some aspects of that HCI environment, but we've got technology right now we're working on that's going to address a lot more, actually going in and through the hypervisor and understanding CPU cycles, how many VMs, all of that different information.
It talks about how the latency varies as the metadata, the size, the sheer scale of the scaled out environment varies by the number of nodes on it, so that would be interesting if you could model that in some way.
Yep.
And how about the emergence of non-volatile memory over fabric?
Oh, we get asked that a lot. So we're definitely looking into how we want to dip our toe into the water, right? Is it going to be Rocky V2, Pure Fabrics? We're in development right now with that. We definitely see the need in the market, and we're definitely working on that right now.
Who would you say was your main competitor?
Freeware, but freeware is really not a competitor. I mean, there's a lot of freeware out there. Some freeware actually can do a great job for a lot of people, but it obviously takes a lot of human time to be able to construct a lot of these tests with freeware. And then if you're just looking at power and cooling and the amount of hardware needed to just match one of our load generation appliances, it's just staggering on the time and the money that it costs. So up front, you think it's freeware, it doesn't cost anything, but you're not looking at those hidden costs, the man hours, right? The amount of hardware, the amount of time that it takes for all of this.
So we had a sales meeting yesterday, and one of the things that came up was really early prospecting of asking the question of how do you test at the moment? And it's amazing how many people just don't. They'll just trust their reseller or their vendor or whoever, and who'll provide it, and then it goes straight into production.
Sure.
So, and
That's what we've been doing in networking for 20 years. Because it's not cost effective to do testing, and the vendor's product should work as advertised. Really should.
yeah, they
and if it
should.
doesn't, you should make the vendor pay. You should make the vendor take the product back. Why should the cost be on you as a customer? It's like, this testing is great, and I agree with you, it's necessary. But effectively, what you're doing is taking your car and then putting it on a racetrack for 2 weeks to validate that it actually performs as promised. And I think one of your biggest competitors is that we are moving past the era of offering substandard products. So public cloud is out there saying we can guarantee you this level of service, or we can provide you, but we don't need. And the vendors are being held to a higher level of capability. They have to deliver on their promises, because if not, we're just going to put it in the cloud.
So that's
I do see there's a need.
Yeah,
There's
no.
definitely a market for your product. But
That
I
is-
wonder if there's a transition coming where testing becomes less necessary as we have more performance, so flash arrays.
I wonder whether putting the car on the test track is a fair comparison. And maybe it's actually taking the car home and making sure your suitcases fit in it, and the dog can get in the back.
yeah.
So we end up sitting there.
The use cases for storage are so much more custom and varied than the use cases.
No,
what
they're
you
not.
do with the
Everybody
car.
uses the same storage array on the same software with the same systems with
Yes,
the same
but their
everything, and not
workload is-
custom. No, the workloads are not varied. They're always the same. I'll bet if you got into this data and analysed, these guys can run tests that every customer can use. So every customer must be the same, or they would never be able to have these standardised tests. It's a myth. It's a myth.
No,
that
the
standardised,
standardised- yeah.
unique snowflake.
The
The
tests
the
are
standard-
standardised, the parameters that
Yeah, the
tests are not.
parameters are not,
Okay.
and so it's the different workloads for different people
If you were
are
truly
very
unique,
different.
you would never be able to create a standardised test where the parameters can just be varied. Then it wouldn't. It's not unique. It's standard.
No, but actually these are not standardised. This is just looking at
Yes, I
a spec of a VMAX box, for example, and then we're taking your individual workload against that.
Matters for my e-commerce system might be completely different from the level of storage latency that matters for your internal record database.
Sure.
But they're
That's
both
a
storage-
trivial. That's a
but
trivial transition. You're fiddling with
Trivial
2% of our-
by millions of dollars potentially.
Yeah.
And some people, like
Yeah.
if we look at some of our big customers, there is a large online trading customer in the US that you will have heard of. The downtime on their online system costs them $75,000 per second. 1 millisecond of latency in their system costs them 1.6 billion over a year. Right? So this is not trivial. It really isn't trivial. So you can say, okay, let's average this out over a whatever, and it really won't matter. Well, actually, in large enterprise systems, it really does matter, and it can run into millions.
I get it.
The other thing you touched on there was the paranoia that every storage manager has got at the moment is basically that they're going to get outsourced. So every one of them, this is a kind of human thing, not a technological thing, of they're having to justify themselves higher up to the business. So if you go to your favorite public cloud vendor and ask them to guarantee you an SLA on the performance of your critical applications that are running your business, they won't. Just fact. They won't. They won't give you anything near that. If you're lucky, they may talk about uptime. They may talk about an availability, whatever. They certainly won't guarantee anything. They certainly won't talk about performance. So, from a storage point of view, this is where the on-premises storage people can really shine, because they can say, okay, let's look at a real workflow, a real application workflow through a system, and we can see how is it actually going to work. We can then offer an SLA back to the business, and that's the language that the business understands. Like, are you going to guarantee this is going to perform? If so, yeah, great, let's keep it in-house, because the external guys won't give us that.
Do you think you should have a technology partnership with people like Spirent and Iaxia in the same way you're working with Gigamon? Or do you see them as competitors?
No, we don't see them as competitors at all.
In fact, we have a lot of employees that are ex-Spirent people.
Yeah, yeah. And again, at the big Cisco trade show last week, we started talking with Garland about stuff that they got, customers who need this, and it's. I think it's kind of early days of that. The traditional virtual instruments business has grown up in the kind of fibre channel space.
Right.
Now that's expanding, as you've mentioned, it's expanding out, but it tends to be, what we're seeing is it's actually incremental to the fibre channel as opposed to replacing that. I'm sure over time there will be movement. But, I was talking to one of the guys at Unilever a couple of days ago, and he's saying, a well-managed fibre channel estate is actually more cost-effective than Ethernet. That's their personal experience of that. Interestingly enough, he also said that he felt that the Internet of Things was coming along. That was going to create a massive additional workload on the on-premises data centers, because they couldn't see any way that they could outsource that to anybody else. It was critical and personal data, so they had to do it themselves. And so there's kind of trends that you're hearing. We did a thing with the Enterprise Storage Group at the end of last year, where they looked at European businesses of trends. One of the interesting things that came out of that is 68% of people who had put something into the cloud had taken it back out again. Now, that's a stat you don't see. So we weren't actually looking for that.
No.
It was just something that actually came out during the questions.
But it just depends on whether the workload was ever a real production workload
Exactly,
versus
yeah.
exploratory. And
Yeah.
also, if you store stuff in the cloud, if you want to get it back, that is taking it back out the cloud.
Yeah.
So if you're archiving, you still bring it back. So
Yeah, I'm a great believer that if you look at the word migration, if you apply that to animals that migrate, you'll find that they come back again. It's not a one-way trip.
yeah, but we see multi-cloud as the emerging trend anyway. So people move between clouds as well as bringing back on-prem as
Yeah.
needs change.
So what we're seeing with our customers is anything that's giving them competitive advantage and is business critical, they're keeping their hands on it.
We maybe 5 to 10% of the people we survey. It's more, can they control it, and do they have the effective ability to migrate it? They're less concerned about, is it running on-prem or in the cloud, in the vast majority of the people we survey.
Yeah, so we're saying it's all about performance of can it perform in the same way? What service levels have I got? What guarantees have I got that it's going to serve that way? And I think there's a kind of another one of these kind of fallacies is that putting something into the cloud is cheaper. From what we're hearing from everybody, it isn't cheaper.
So it's our
it's
sixth
just
or seventh criteria.
Yeah.
Usually it's flexibility, adaptability, and speed.
Yeah.
Speed of change.
Yeah. But if you've got a highly spiky application, so you're a reseller and you only sell Christmas trees, that's a really good reason for using storage expansion from a cloud supplier to be able to take that capacity in December. Most of the rest of the time you're not going to use it. But again, it's one of these circular discussions. Cloud is here to stay. It has a place, but if you are a car manufacturer and you're running your supply chain that is just-in-time manufacturing, are you going to give that to AWS? Probably not.
Be surprised. SAP on AWS and now Azure is quite popular, and there's major car manufacturers running SAP out the cloud. So it's happening.
Yeah.
It's amazing if you go to an AWS event aimed at end customers and they come out as evangelists. They are running mission critical stuff.
They're actually running it better than they used to on-prem. And part of the cost is how do you upgrade your data center when it comes to a 5-year refit? You cannot upgrade it to the same standard that the public cloud can often do. So you have that choice.
Your OPEX is never going to be as low as cloud OPEX, because they literally do it for a living.
I mean, if you look at how cloud operates as an automation orchestration entity, unless you're in the top 3% of enterprises, you are a major order of magnitude off your efficiency and cost of operations. You just can't get close.
I got a question about the importance of hardware, because you have a 2U box. You're saying to generate this sort of like level of workloads, you need about like 10U worth of traditional servers. What about the virtual appliance? Basically, if you decide to opt for a virtual appliance and you have a VMware stack, like how many servers do you need, and is that sort of like comparable to the box you're making yourselves?
So we've got minimum, and remember, the virtualized portion is the enterprise UI. It's not the load generation. So we do provide lists of minimum requirements, CPU and memory, that we would say, hey, look, you need to do that if you want to have a good experience and have enough speed here.
So how many just like like traditional, just like average servers are we talking about?
I would have to look at the minimum requirements. It's just basically hypervisor requirements that we have. But as far as the load generation, we generate that much load because we basically have rebuilt the TCP stack from the ground up, so it's all our IP in there. And basically rewritten, and the kernel is basically designed to do nothing but generate workload, right? It doesn't do anything else. That's how we can get such high performance out of the product.
So you would first recommend sort of like hardware-based solution, and then if you can't do that for some reason, then you go with virtual,
or a lot of customers say, hey, I don't really have any room in where I'm working to put that in. Say, hey, I've got a great hypervised environment, so we just send them a link and they get the VMs on there.
Okay.
Yeah, we've got basically a small installation and a large installation, and there are different requirements based on those two there.
And a bit of a silly question, but why was it called the Swift Box? Is it because of OpenStack, or it was just a brand name?
It was just the name that they came up with. Swift test, maybe I can generate a test swiftly, I don't know, but too many people, it was in the heyday when OpenStack started getting pretty popular, and they just said, okay, we need to change this.
Nothing to do with small migrating birds.
It's keeping the people that print the business cards in business, because we have a name change every once in a while, and need for new business cards.
Yeah. And hence, Workload Wisdom 6 will be available from the 20th of the month. So just to
20th of February.
20th of February, yeah. That's the launch date. So you'll all be sent the release on that. Fred will make sure that gets to all of you. So just to kind of wrap things up, hopefully you understood exactly where we are in this. The important thing is if you are a cloud provider, you're using this technology. If you're a big software vendor, if you're SAP or you're Oracle, you're using this technology. If you're an end user or a hardware company, you're using this technology. So it's got a very solid customer base of all the people that, where it matters, it's in there. Where we're growing the business is really into the end users who want to have an independent view of that environment. And so that's what we've been showing you today. And we touched on it, the kind of Workload Central. But if you do want to see it, if you do want to look at some real stuff, then workloadcentral.com is a free resource where you can go and have a look and see what you think.